discuss one important aspects of functions. Storage classes in C language. What exactly mean by storage class? When we say this, probably it might correlate with some of the terms which we have already said with the functions. But the only concept is how exactly we carry out these words with respect to these functions. What exactly I mean by this particular term storage class? When I say this, it actually defines the storage space of a variable in memory. When I declare a variable as a int a, either in main or in a function, where that particular variable gets stored defines what exactly is a storage class. So you might carry out that task in main, you might carry out that task in function, in second function, third function, in the middle of the function. Wherever you declare a variable is going to occupy some space. When I say some space, what exactly is the storage space for that? There are two storage spaces basically for a variable. One, we call it as a memory storage class, and the other we call it as a resistor storage class. What exactly I mean by memory, what exactly I mean by storage class? Now, assume that this is my motherboard. Let's now dig into the hardware of this particular computer language. Let's go into the hardware of the system. On the motherboard, the component where the processing is done, we call that as a processor. Let's say this as a processor. Basically, a processor will have an arithmetic and logical unit. And this is the place where the entire mathematical operations are going to be done. We say that this is purely a mathematical region where operations are going to be carried out, but it doesn't have any storage path. There is one more slot on which a primary memory called as RAM is installed. You heard this particular term RAM regularly. Onto your desktop, onto your mobiles, we have this RAM. Higher the size of the RAM, faster will be the capacity of execution. If I have say 3 GB of RAM, 4 GB of RAM on a mobile device, definitely that tends to execute more faster, provided that there is a faster processor. If I have a very slow processor and a very high memory, the device will not work faster. So always correlate the processor and the RAM. A processor has to be speed enough and the RAM capacity has to be large enough. Suppose if I have a mobile device which has got a 1 gigahertz processor, but I have a 4 GB of RAM, that will not serve the purpose. Many people are under the misconception that higher RAM means faster the device. No. Higher RAM along with a higher processor will actually make the device to work faster, whether it is into your computers or into your mobile devices. If I have a Core i5 machine with say octa-core 2.5 gigahertz or 7 gigahertz or 6 gigahertz, and then if I have that particular device which works with those high capacity RAM, 4 GB, 3 GB RAM, definitely the processor is going to be said much more faster. So one storage unit where we generally store the variables is RAM. When I declare a variable as int a, from the first day of learning process of C language, this a used to always get stored in this particular RAM itself. This is the storage class of this particular RAM, that is memory storage class. But there is one more storage space where I can make this particular variable not to be stored into RAM, but to be stored into this particular processor directly. By declaring a variable with a keyword called as resistor, I can say int b. A will be stored into RAM, whereas B will be stored into processor. What difference does it make when I store a variable into processor, when I store a variable into RAM? Whenever a variable is stored into RAM, it has to go to the memory, it has to go to the processor for operation. Suppose if A has to be operated say 1 million times. 1 million times A has to transit from RAM to processor, processor to RAM, RAM to processor, processor to RAM. How good it will be if this B has to be operated for 1 million times and this B gets stored in the processor. If I have to operate 1 million times on this particular B, the processor can access the variable directly without any external support. So hence we say that a variable which is stored into processor is going to be much faster as compared to the variable which is stored into RAM. So it means that a variable can be stored into the RAM. This is my total motherboard. And this is RAM, this is a processor. So variable is stored into RAM, a variable is stored into processor. When a RAM is stored, the variable tends to get slower, and when it's stored into register, it tends to get executing faster. So basically, when I say memory storage class, if a variable is stored into the primary memory, that is RAM, we call that variable as a memory variable. If a variable gets stored into the processor's register itself, we call that variable as a register variable. So basically, we have two storage classes. Now, let's identify the advantages and drawbacks of both these storage classes. When I say a register storage class, the advantage of this is that the variables tend to get executed faster. I said if a B is supposed to be executed for 1,000,000 times, the results will be yielded by this particular B much faster than A. If that could have been the case, then every time I could have used resistor so that my program would have been executed much faster. It doesn't happen because your resistors are limited in quantity. Higher end processors, maximum say 1000 or 700 resistors altogether, of which most of the resistors are used by the processor for its own purpose, and only few resistors are allowed for the user. So we have only limited quantity of resistors, but execution speed is going to be much faster. So the advantage of this is that the processing speed is more. The drawback is the limited quantity. And moreover, we cannot expand the resistor size. Once the processor is designed, say Core i5, Core i7, you take any processor, it comes with a fixed number of resistors which cannot be changed. Now, let's move on to the memory variables. Memory variables comes in a large quantity. You'll have say 1 GB, 2 gigabytes, 3 gigabytes, 4 gigabytes of RAM. It means that I can have much larger storage space. You can expand this particular RAM. Suppose if my computer needs some additional RAM, I can purchase a RAM from the hardware shop and insert it onto the motherboard. So memory variables can be expanded. Memory storage class can be expanded. Register storage class cannot be expanded. With respect to processing speed, register storage class has got an advantage. Memory storage class doesn't have any, but will be slower. It will not be dead slow, but it will be slower when we compare with resistors. So basically we have two storage class. One is memory and the other is register storage class. Again, this memory storage class, again in this RAM, we have some additional variables. It all depends upon the place where we declare these variables. Whether we declare the variables in function, before main, within main, outside the function, depending upon that, we are going to classify this memory variables as automatic or local variables, external or global variables, static variables. You can experience this even in the register storage class also. So basically, storage class, let's summarize this. Storage class defines the storage space for the variable. There are two storage class, one is memory and the other is register storage class. If a variable is stored in the RAM of the processor or external to the processor, we call that as memory variable. If a variable is stored in the registers of the processor, we call that as register variable. So advantage of register is only speed is faster. Drawbacks are limited in quantity, non-expandable. RAM advantages is it is expandable and large in quantity, whereas one drawback is slower as compared to register. So this is about the classification of storage class. Thank you.